As I was saying a little bit when we were reviewing there, the new transformation we're going to talk about today is a reflection. So when you have a reflection, it just flips over, doesn't it? The reflection is really just a flip over. Give me some examples of some reflections, maybe in our world around us. Think of any? Dakota? Water. Okay. So what happens on water?
It's like perfectly still. It's like painters, they can draw the mountains, and the water's perfectly still, you can draw the mountain reflection on the water.
There's a reflection of something on the water, so it could be a mountain. Okay.
Just to give you a heads up, they've been talking about reflections in physical science.
Oh, and what, in what
Like the
sense?
sound waves, how they, remember the incident? Reflection, and then what happens?
Then
If there's a
there's an opposite.
flat barrier,
Yeah.
right?
It's kind of like a bounce back and a reflection?
Yeah.
Yeah.
At the same angle, so it's,
Okay. So we're doing it in science. Oh, awesome. Okay. Anybody else have something that they were thinking of that they want to make sure? Isaac?
A mirror.
A mirror. When you look in a mirror, you get a reflection back. Does anything, nothing changes. It's reflecting exactly what you look like, right? Okay, so anything else as you thought of Trey?
Glass.
Did you say glass? Okay, and what about glass?
You can see a reflection.
Okay, so sometimes in glass, the
Clean glass.
okay, clean glass, you can use it as a mirror almost like? Okay. So here's how we're going to decide if a reflection happens or not with our line graphs. Okay, it says, when the slope of a line is multiplied by -1, the graph is reflected across the y-axis. What's the y-axis? Show me with your arm. What's the y-axis look like? Like this, yeah. So it reflects across the y-axis. If it was over here, it's now on the other side, yeah. It's not going to go up or down, it's going to go left or right, isn't it? It's going to reflect across the y-axis. And notice what it said, it says when we multiply by -1. Let's underline that. When the slope of a line is multiplied by -1, the graph is reflected across the y-axis. When the slope is multiplied by -1, the graph is reflected across the y-axis. In other words, it flips over our vertical axis. It moves from the left side to the right side or right side to the left side. So here's what they have for an example here for us. They show us the graph of g of x equals 4x. And then so it's right here, g of x equals 4x. Here's our line right here. And then they reflect it across the y-axis. And they say that the equation for that one is h of x equals -4x. What happens when you take +4 times -1?
Positive forward.
When you take +4, when you take +4 times -1, what happens?
Negative.
Not right.
They're just opposite.
You get its opposite. You get -4. So notice what's the slope of h of x? So the slope of this one is 4. What's the slope of h of x? -4. Did its y-intercept change?
Cassidy Tiskey to the senior high office, please. Cassidy Tiskey.
So its y-intercept didn't change. The only thing that happened is the slope changed to its opposite. Or in other words, it's the opposite sign. Right now we're going to observe that. What's most important is it's its opposite. And in opposites, they have opposite signs, don't they? Okay? So we have, and does this look, remember our y-axis is what it's reflecting across. So does this side look like it came down here and bounced back and ended up over there? Like we were talking about, okay? So when we have a reflection going on, we should end up with the slope being multiplied by a -1. Okay, now let's look at what it says over here, because this is the other thing that's going to happen today. It says, more than one transformation can be applied to a linear function. More than one. How many do we know now? 3. What are they again? Yesterday? Translation, rotation, and now today we're adding reflection. So we have 3 different types of transformations that can happen. So notice what they have here. They have graph f of x equals x. What's that one again? Would you write that over here, by the way? F of x equals x. What's that one called again? The parent function. That one happens to be the parent linear function. What's its slope again? 1. What's its y-intercept? 0. Okay. But then now they have g of x because f of x was transformed and its equation is 2x take away 3. What's its slope? 2. What's its y-intercept?
Negative 3.
-3. Okay, what changed? Cameron, what's one thing that did? The slope changed. Did it change to an opposite sign? No, they're both still positive, aren't they? So could a reflection have happened if they're both still positive? No, no reflection happened here. Okay, what happens then if the slope changes and they stay the same sign? They're both positive like they are. What kind of a transformation happened then? It got rotated, didn't it? F of x was rotated. Did it get steeper or less steep? Okay, here's the parent function right here. Right here. They got a graph for us. It's right there. And here's our new one. Is right here, the red one. This is g of x right here. Did it get steeper or less steep? It got steeper, didn't it? Yeah. So this one had a rotation. It says the slope of g of x is 2, so the line is rotated and steeper than f of x. And then, did anything else change? Go ahead, Ariel.
The y-intercept change.
Yeah, the y-intercept also changed, and if the y-intercept changes, what does that mean happen? A translation. So it also has been translated down 3 units because it went from 0 to -3. So 2 transformations happened, didn't they? Both of the ones we learned yesterday. Okay, let's go and just start practicing some of this. Let's look at number 1. It says graph g of x equals 1/3 x and h of x equals -1/3 x, and then describe. Okay? So let's write our functions down just like we did yesterday. G of x equals 1/3 x, and then our other one is h of x equals -1/3 x. And by the way, they get to use whatever letters they want. It really doesn't matter which ones they use. It can be F, it can be G, it can be H, it can be J, it can be K, it can be any of them. Okay? So what do we have to identify for both of them? Every single time we do this.
The slope and linear.
The slope and the y-intercept. So the slope of this one and its y-intercept, the slope of this one and its y-intercept. First of all, we need those to help us graph them too, don't we? Okay, so the slope of g of x is 1/3, and the y-intercept is 0. The slope of h of x is -1/3, and its y-intercept is 0. Okay. Anybody want to predict right now what they think is going to happen on that graph? Get a mirror. No. Okay, what's that mirror called again? What type of transformation? Reflection. Okay, anything else? I think there's only going to be a reflection. Okay. Well, let's graph them one line at a time. And notice I tried not to just baby you through graphing anymore because this should be kind of old hat. We should be able to do that pretty easily and quickly. And remember, on the graph, it's always a good idea to give them their names, like f of x or g of x or h of x, whatever it is, so you can keep them straight. Do you think we can still agree with what we decided, that it was a reflection? Yeah? Okay. So reflections will oftentimes also look like rotations, right? Because couldn't we call this a rotation also? Didn't the line really just turn? So oftentimes it's hard to say, well, how come we couldn't call that a rotation also? Well, when it's a mirror, like I heard somebody say, when it's a mirror, then we don't need to talk about a rotation, we can just describe it as a reflection. And the y-intercept didn't change, so it didn't translate. So we're going to say for this one that g of x is reflected across the y-axis. G of x is reflected across the y-axis. Because reflections can happen over the x-axis too and over other things, so we do want to be specific and say across the y-axis, okay? And notice, are those lines perpendicular? What do you think? Do you think those are perpendicular lines? Okay. Should they be perpendicular? No, they don't have to be, but should they be according to their slopes? They're opposite signs.
Yes, but it's not a.
Oh, but they're not reciprocals, are they? That's why they don't form right angles, because they don't have reciprocal. They're opposites, but they're not also reciprocal, so that's why they don't turn out perpendicular. Okay, they are intersecting though. Okay, anybody got questions about that one before we talk about go on to number 2? This is the only graphing we're going to do in our notes. On the back side, we're going to try and describe them without graphing and hopefully give you some more homework time today. Okay, then let's do this one says the same thing, graph them first. So f of x equals x, and our g of x is 1/2 x, take away 3. Okay, so this happens to be the parent function. We got that one memorized. M equals 1, b equals 0. F of x isn't always the parent function. I hope you discovered that in your homework. What's the slope of g of x?
1/2.
1/2. And the y-intercept of g of x?
-3.
-3. Okay. Let's just predict, and then we'll see how the graph supports it. Let's predict what we think should happen. Anybody want to predict what they think is going to happen here? From f of x to g of x, what's going to happen?
Well, I think, wouldn't g of x be steeper than f of x?
Is g of x going to be steeper? Remember, what was our rule for it getting steeper? If it's greater than 1, then it gets steeper if you're comparing it to the parent function. Or in other words, the larger the number gets, the steeper it gets. Okay? So is f of x going to get steeper when it becomes g of x?
No.
It's actually going to flatten out and get less steep. It should, that's what should happen. So what's that called when it gets less steep or gets steeper? What kind of transformation goes on?
Rotation.
Rotation. Okay, is there going to be a reflection, do you think? Why not?
They're not opposites.
They're not opposite signs. No reflection this time. How about a translation?
Yes.
Okay, in other words, they don't share the same y-intercept, so we think there's going to be a translation too. In other words, they won't cross the y-axis at the same place. Are they going to be parallel, do you think? No, because why?
Translation.
Because not only did they translate, but they also rotated. So remember what I said, when more than one thing happens, then we're going to probably lose the parallelism. And we can see right here, we have to lose the parallelism. They don't have the same slopes anymore. Okay, let's go ahead and graph it and verify that we think that's what we think happens. We start, let's get our parent function graph. Okay, remember what we predicted? We predicted that there was going to be a rotation, and we predicted that there was going to be a translation. So this one, f of x is slid down, isn't it? Even though it's not parallel, it is slid down. It doesn't have the same y-intercept anymore. So there's our translation. But it's also, did we decide it's going to be less steep? Yep, and it doesn't look less steep. So we have that rotation that happened also. So we're going to say f of x is, let's start with the translation. That's the first one we learned yesterday. F of x is translated down 3 units. F of x is translated down 3 units. We always have to talk about direction. You can't just say it's translated 3 units. You're going to say up or down. So it went down 3 units and is rotated and less steep. And is less steep. Okay, now we're going to take a little breather from graphing, but on your homework you're going to have to graph, okay? But on the back side, we're just going to try and practice these without having the graphing going on, okay? So let's go to the back side here. First of all, let's do what they're asking here. It says each function below is reflected. So they're telling you that f of x is going to get reflected across the y-axis. You have to write the new function. Reflection. What happens in a reflection? Slope. Yeah, so slope gets multiplied by, what did it say in the front? So we have to take m times -1. That's all we got to do, you guys. We just have to take m times -1 and we'll have our new function. Well, what's m? What's m in our first one, number 3? 5. So we're going to take 5 times -1, and what are we going to get? -5. So our function's now going to be g of x equals -5x. That's that easy. So, number 4. F of x equals -9x. Its slope is what?
1.
No, f of x equals -9x, -9. Take it times what? -1. What is -9 times -1? Positive 9, so g of x equals 9x. Okay, remember we're only reflecting, that's all they're having us practice doing here. F of x equals 2x plus 7. What's its slope? 2, yeah, so we're going to take 2 times what? -1. What do we get? -2. So now it's going to be f of, or not f of x, how about g of x? Yeah, thanks. G of x equals -2x plus 7. We don't want to change its y-intercept because it didn't translate. It only reflected, didn't it? Okay, so just a little practice there of being able to write your own functions. Okay, so here's what we're going to do. We don't have to graph, we just have to describe it. We're still going to do the same thing we were doing when we were graphing. We're going to say, if we have f of x equals x, and we have g of x equals 4x minus 2, we still are going to identify their slopes and their y-intercepts to help us decide what would happen on a graph. So first one's our parent function, isn't it? F of x equals x. What's the slope of our other function, the transformed one? 4, and its y-intercept is? -2. Okay. Anybody want to offer up what they think is a transformation that occurred, Trey? It rotated. How do we know it rotated?
Slope change.
The slope changed. Okay, so it rotated because it went from 1 to 4. So if it rotated, so let's start describing. F of x is rotated and gets what?
Steeper.
Steeper. How do we know it gets steeper?
It's.
Josh, how do we know it's steeper? Yeah, 4 is bigger than 1. If the slope got bigger, then that means it got steeper. Okay, so is that the only thing that would happen on this graph is a rotation, Ariel?
There's a translation,
Oh, and a translation happened, and how do we know that?
because the y-intercept changed.
Because the y-intercept changed, so we're gonna say and is translated, how? How are we gonna describe its translation? Down 2, it went from 0 to -2, so we went down 2. Any more ands? Did it reflect? Would it reflect? How do we know it doesn't reflect?
It's not the opposite.
They're not opposite signs, are they? They have the same sign, so there was no reflection that went on. Okay, I want you to try number 7 on your own. Do it just like we were doing here. Write down your functions, identify the slope, identify the y-intercept, and then see if you can describe the transformation or transformations that happen. I'll give you a little hint. 2 transformations occur in number 7. So there were 2 transformations that happened. Anybody ready to offer up one of them? Siobhan, what do you think is one of them?
I said f of x is translated out by 3.
Okay, so f of x is translated up 3. Everybody agree with Stefan on that one? Are you cool with that? It says it translated up 3, okay. And I said there were 2, so what would the second one be? Dakota?
It is rotated in parallel steep.
And is rotated, and what was the end of that? And
It is now less steep.
is now less steep. Okay. Or in other words, gets less steep, whichever way you rolled it. Okay. Everybody agree with Dakota on that? It rotated. Why did it rotate? How do we know that?
Because it was so
Because
steep.
of the slope change. Okay. And how do we know that it got less steep?
That 0.25 is less than
Yeah, 0.25 is less than 1, which was the original slope. So if it gets smaller, then it gets less steep, okay? And how come a reflection didn't happen? How do we know that a reflection did not happen?
1.
Slopes aren't opposites, they aren't opposite signs. So if they aren't opposite signs, we don't have to say anything, there was no reflection, okay? Okay, everybody get that one? Everybody was successful? Any questions? Okay, then we got just a couple more here to finish, let's go. F of x equals 2x. G of x equals x plus 8. M equals, B equals, what's our f of x, m this time? 2, not 1 this time, because this isn't the paired function. What's its y-intercept? 0. Okay. What's the slope of g of x? 1. And its y-intercept is
8.
8. Okay. So, we're ready to describe what we think the transformations are. F of x is what? What's one of them we can say? Shamarki?
Is less
Okay. So what causes less steep? First of all, what kind of a transformation? Not translated, what steepness gets changed by what transformation? Rotation. So rotation. So f of x is rotated and gets less steep, right? Is rotated and gets less steep. Now, this time it's a little bit tricky because the new slope is 1. How do we say that? Because we can't say, well, it got less than 1. How are we going to compare this time? It started as 2 and it went to 1. Did it get smaller? Yeah, if the slope gets smaller, it gets less steep. If the slope gets bigger, it gets steeper. Yeah, it gets more steep. Okay, so is rotating gets less steep? Is that all that happens?
No.
Mia, what's another thing that happens?
It's translated up by 8.
And is translated up 8. Yeah, and is translated up 8. We went from 0 to 8. F of x is rotated and gets less steep and is translated up 8. Yes, Dakota?
Can I go up there and do number 9?
And you go up there and do number 9. Sure, come on up. Okay, you guys are gonna do it with him, okay? So, if you need to challenge him, we challenge him respectfully. You can just rip his finger. Works better than the pen on this board for some reason. Probably wanted to bring your font down a little bit, we're not gonna make it. Yes, Marky.
if B was negative, what would it be for the translated?
So if B was negative to start with, you mean, or it moved to a negative?
Like it was a negative 8. Like that was a negative 8 right now, what would it be?
Okay, so if it, first one was 0 and the other one would be negative 8, then we would say it went down 8. Because you think of it kind of like this. You start at, it started at 0, and then it went to positive 8, so that means it went up 8.
Okay.
If it starts at 0 and it ends up at negative 8, it has to go down 8 to get there. Let's say one of them started at negative 4. Let's say it started at negative 4 and then it went to 2. It went up how many? 1, 2, 3, 4, 5, 6, right? And then it would go up 6. Okay, so everybody agree with Dakota so far? He's got his slopes and y-intercepts identified. Everybody agree with him so far? Okay. Go ahead, Dakota. What do you want to do next with these guys? It got rotated, he says. You guys agree?
Now more steep.
And it's now more steep? Oh, you guys agree? F of x is the, remember the beginning one. I disagree.
F of x
It's
is
more
rotated.
steep.
F of x is rotated.
It's less steep.
It gets less steep because
you're adding.
Because in reality, we're going to kind of ignore the negative sign and we're going to say it's 5 units of absolute value.
Oh,
Is 1 less than 5?
it is less steep.
It is less steep, right? So we can write that. Go ahead and write it. F of x is rotated and gets less steep. F of x is rotated and gets less steep. Okay, how do we feel about that? Is that the only thing that happened then? Cameron?
And is rotated.
We already said it was.
Reflected, rotated, and reflected.
And is reflected. Oh, and how do we know it got reflected? Yeah, the sign changed from being a negative to a positive slope, so that means there's also a reflection that went on. So f of x is rotated and is less steep, and is reflected across what? The y-axis. So f of x is rotated and is less steep. And, we've said it, it's also reflected across the y-axis. Any more hands? We still have one transformation left. Was it translated? How do we know it wasn't translated, Josh? Y-intercept didn't change. If the y-intercept doesn't change, there was no translation, right? Okay. So, thanks, Dakota. How do you feel about this? Think you got it? Thumbs up if you do. If you don't, that's all right. You can just be asking for help while we're working with you, right? Okay, then let's get ready. I'll get your worksheet.